Okay, for what we have in the next problem, we're looking at trying to determine the Laplace transform of the square of sine of t. And to be able to work with this and to make everything as integration friendly as possible, if we write the square of the sine of t in terms of its double angle equivalent, where we have 1/2 minus 1/2 of the cosine of 2t, we're going to have for the Laplace transform, okay, this will be the result as we take the improper integral as t goes from 0 to infinity of 1/2 minus 1/2 of the cosine of 2t quantity multiplied by e to the negative st dt. Looking at what we have for the general integrals, so we have from the 1/2 portion, so we can say we have 1/2 of the integral of e to the negative st dt. If we apply u substitution just for the first term, so we have that u is equal to negative st, and taking the differential in terms of what we have in u and t, so we have du is equal to negative s dt, and expressing dt in terms of du, so we're going to have dt is equal to the negative of du over s. So we got in the layout, so we'll have 1/2. And so we have of negative 1 over s times the integral of e to the u du. So we have negative 1 over 2s. And we have times e to the u followed by the constant and back substituting. So we're going to have the negative of e to the negative st. Again, since we had substituted u for negative st, so you have the negative of e to the negative st all over 2s followed by the constant. Okay, so we're looking at subtracting 1/2 of the integral of the cosine of t, make that the cosine of 2t, times e to the negative st dt. And if we integrate what we have here, just for the cosine of 2t times e to the negative st dt, now we're looking at what will be repeating integration by parts. So if we set u equal to the cosine of 2t, and dv equal to e to the negative st dt. Alright, now u at the cosine of 2t. Okay, if I take the differential of both sides, I'm going to have that du is equal to negative 2 sine of 2t dt. Okay, so you have for v, the antiderivative. Okay, so you have negative e to the negative st all over s. And we have with the integration by parts, so we have u times v. So we're going to have negative cosine of 2t times e to the negative st all over s. And we have subtracting the integral of the product of v du. Okay, you have a negative times negative is a positive. I'm applying subtraction. And we have with the variable factors. So I have the sine of 2t times e to the negative st dt. And we have for the next round of integration by parts. Okay, so I'll let u be equal to the sine of 2t. And taking the differential, okay, so we're going to have 2 cosine of 2t dt. And we have that dv is equal to e to the negative st dt. And reapplying the same antiderivative. So we have negative e to the negative st all over s. And for what we have in the follow-through, so you have minus 2 over s. And for the next round of integrating by parts, you have u times v. So we're going to have the sine of 2t. In fact, not just sine of 2t, but the negative. It says I have negative st over s. So I have the negative of the product of the sine of 2t and e to the negative st all over s. And we have within, in case you have subtracting the integral of the product of v and du. Okay, so you got negative times negative is a positive, and so we have plus 2 over s times the integral, so we have the cosine of 2t times e to the negative st dt. And if we go back, okay, so we started out with a cosine of 2t e to the negative st dt. So looking at what we have so far on the right hand side, okay, so I have, once again, I have that cosine expression. And looking at distributing 2 over s, so I have a negative times negative is a positive, so this is going to be plus 2 over s squared times the sine of 2t times e to the negative st, and we have negative 2 over s times 2 over s, and this is going to be minus 4 over s squared times the integral of the cosine of 2t times e to the negative st dt. And if you notice, we have like integral terms in the integral of cosine of 2t times e to the negative st. We're going to have cancellation. And now, if you notice, you have 1 plus 4s squared quantity times the cosine of 2t e to the negative st dt. And if I were to combine these integrals and consolidate, we got 1 plus 4 over s squared. So in this case, okay, we're going to have the quantity of s squared plus 4 all over s squared. Okay, we have times the integral of the cosine of 2t times e to the negative st dt. Okay, so this is what we have here. And so if I isolate the integral term, what I can do is I can multiply by the reciprocal. In other words, divide by the coefficient. So I'm just going to multiply the reciprocal. So if I have multiplying by s squared all over s squared plus 4, and multiplying, so you have s squared over s squared plus 4. So we have s to cancel out, so we have 1 degree in s left over. And in this case, you're going to have negative s times the cosine of 2t e to the negative st all over s squared plus 4. And for 2 over s squared, if I multiply by s squared over s squared plus 4, the s squares will cancel out. So we have plus 2 over s squared plus 4. We have times the sine of 2t times the e to the negative st, and then we have followed by a constant. So looking at what we have, just going back to our original integration term. And so we have, upon distributing, okay, so we have a negative times negative is a positive. So we have s cosine of 2t times e to the negative st. We have all over 2 times the quantity of s squared plus 4, and you're going to have minus 1/2 of 2, so that's going to be minus the sine of 2t e to the negative st and we have minus c over 2, and by then you can just write this as alpha. Okay, so looking at consolidating what we have earlier for the Laplace transform. So we have the limit as b goes to infinity. Notation. So you have the limit as b goes to infinity. And now for what we have in the antiderivatives. So you have the limit as b tends to infinity. Okay, so looking at consolidating all together. Okay, so we have this set of terms, okay, and we're looking at going from 0 to b as b approaches infinity. So we have, in the case of what we have in the upper limit, okay, so we have at b, and so we're going to have in this one, okay, so as t approaches b, while b tends to infinity, okay, so we're going to have e to the negative s times b over 2s, and you have plus s times the cosine of 2b times e to the negative s times b in the numerator, and the last numerator we have the sine of 2t times e raised to the negative s times b. And we have with the lower limit, okay, so you're going to have with t at 0, okay, and we had the simultaneous subtraction of a negative, so that's going to be plus 1 over 2s. You have e to the 0 is 1, and we have over 2s. And guess what? We have at 0. Okay, now the cosine of 0 is 1, and e to the 0 is 1. And so we're going to have minus s all over 2 times the quantity of s squared plus 4, and you had the sine of 0 is 0, so this term is going to be negligible. And for what we're going to have, looking at the terms that contain the variable b, and carrying over, okay, so again we have the negative of s e to the negative s times b, okay, and so we have for this particular item, okay, you got the negative of e to the negative infinity, and so you're looking at 0 on the decreasing side, but that is still going to be essentially 0. And the same thing here, we have e to the negative infinity. Okay, so you're looking at tangent to 0, okay, and that would happen to be negligible. And for sine of 2t, e to the negative infinity. Okay, so you have b approaching infinity, and opposite sign of infinity is negative infinity, and e to the negative infinity, again, that tends to 0. And so with these first three terms becoming negligible, and just doing a little bit of backpedaling, and it will not change the result, but I just want to mention I overlooked the t. That should have been changed over to b. And nonetheless, so just making this little technical correction, but nonetheless, the first three terms are going to become negligible, and we end up with the same result. We're going to have, for the final answer, we're going to have 1 over 2s minus s all over 2 times the quantity of s squared plus 4. And you can expand this. And another way that you could express, okay, is that if you were to combine as a single ratio, and in this particular case, all right, so that would end up being at 2s squared plus 8 minus 2s squared over 2s times the quantity of s squared plus 4. And notice we have, with the even coefficients, notice we're going to have 2s squared and negative 2s squared are going to cancel out. So, and with 8 over 2s, and so this will be reducible to 4 all over s times the quantity of s squared plus 4. So these are two ways that you can express the result for what we have in the Laplace transform.